Hi, welcome to another edition of a demonstration for generative design. Here I have Revit 2023. You can also use 22 or 21, it doesn't matter. And then I click on my uh, Dynamo and open my Dynamo. And inside the Dynamo, I'm going to create a script to show you how we can build a study, a generative design study. So in order to keep the time simple and fast and make it quick, so I've already developed this script, which I'll explain to you so that you can understand. And it's very simple script. We have one set of nodes here called inputs and one set of nodes here called outputs. The inputs are what we define in order for our study to take place, and the outputs is what the computer will churn it out for you to say that, okay, look, this is the best option you can have, because it will generate multiple options or multiple alternatives of the design. So this particular generative design script is very simple. It is just generating one big mass like a cuboid or a cube or a cuboid by using the values of length, width, and height. And they range from 0 to 100, because when I define here, the minimum is 0, maximum is 100. So we can keep it simple, or we can even make it different heights in our study. So let's see that how it goes. Then we feed this into this node, which will create a solid, a 3D solid, and this solid need to be broken into six surfaces, and this six surfaces surface area is collected in this node, and this node is a math sum node, which has been renamed as surface area. So what it does, it takes all the six surfaces and then adds it up so that you will get the total area. And then this node, the output node, is the volume of that mass, building mass, which comes straight from this cuboid. Okay, so you can forget the color palette node for the time being. So once I am done, I have done this, and I need to verify whether my script is ready for creating a study, a generative design study. I go to the extension here, I click on the graph status. So when I click on the graph status and graph properties, for example, let me do a zoom all here, and then if I go to generative design here and click on the create study, all right, and sometimes if your graph has not been run, there will be some issues, but if it has been run once, then it should be okay. So uh, the better thing is first to run it. So let me run this graph first so that we know that this particular graph is error free. So you can see here that I have this object here, which I can rotate it and see there is a mass produced, right? Building mass is produced. So now we go back to the generative design and click on the create study. And when we click on the create study, we will get create study dialog box like that, which in which we have to define where is our code, where is our Dynamo script. So for example, here under the choose folders, if I choose Autodesk samples, I will get all the samples provided by Autodesk for doing certain different types of studies, design studies. Mine is stored in example 2 here, okay, and it is called surface area volume, right? You can see here at the top, surface area volume dot dyn. That is the script. So I want to use this script to do my study, so I click on that. When I click on that, then it comes out with the define study. In the define study dialog box, we have to first give a name for this study. So let's say we call this name as building mass, optimum size, or just say building mass, okay. And we have four different ways to use this study, either to randomize the study, like computer choose different random numbers or random options to generate the volume, or we can space evenly. That means we can say for every 10 meter 10 meter 10 meter 20 meter 20 meter 20 meter, do some space evenly, or we can optimize. This is what we want. So for a given uh, volume, what would be the minimum surface area? So we want to reduce the surface area because the surface area will have, let's say, the curtain wall, and curtain wall is being expensive. So we want to keep the volume maximum and the surface area minimum. So we click on optimize. Like this option is the same as optimize, but it will be filtering much more. You can filter here. Once you optimize, you can use like this to further filter it to get your best options. So I choose optimize. The height of the building, the length of the building, and the width of the building. Maybe the length we say cannot be zero, so we can say minimum should be around 20 meters or 30 meters. Width also should be minimum 30 meters, and height can be from 0 to 100. Zero, of course, will not generate any volume. It will generate a surface only. If I make all of them zero, then there may be a problem, right? So next comes the goals. These are the design goals, right? So you have to be very careful when you do a study to set the goals properly. So in this case, I told that our surface area should be minimum, so minimize. Our solid volume should be maximum, so maximize. So this is my design goal. And now the computer will go and look from 0 to 100 or 30 to 100, 30 to 100 and generate different volumes or different building mass, wherein it will say that this is the best option and this is the next best option, and so on. You can also set some constraint to say that my minimum volume should be so many cubic meters, maximum should be so many cubic meters, or minimum surface area for this should be so much, or maximum should not exceed something. But I will keep this open for the computer to determine. The next option is generation setting. This is for the computer to generate different options, and once it generates, let's say, 100 options, then it will take 25% of the 100 options and then put it for the next iteration, or what we call the next generation, so that it will refine that until it stops. And this is the number of iterations. Generation here means how many times it will do again and again. So the more you give, the more refinement you will get. Of course, more time the computer will take. The seed is something you can define a number, a random number. In this, every time you change the seed, you will get different designs. All right. So once we are happy with this, if there are no issues, now it is ready for generating. So I can click. The issues will be shown here. If there are some problems in your constraints on your design goals or your inputs and outputs, then the issues will come here and you will not be able to do the generation. Since now there are no issues, I'm going to click generate, and the computer will take depending upon how fast is your computer, it may take few minutes or few seconds, and it will generate as many options as it can in that 10 different iterations, right? So I think now it has defined, I don't know how many it has defined, maybe we can say each line is 1, 2, 3, 4, 5. So see, 10 out of 10 iteration is complete. So we can say it has generated, I don't know, it should be somewhere here, the number. Never mind, but we can always see that number of iterations here, or number of alternatives. This is a 3D object, so you can click on the 3D object and then you can see that this is very tall, where the height is 100 meters, the height of the building. But let's say because there is a regulation, we don't want 100, we want from 20. We can filter it further here, 20 meters to 100 meters. So we push it down here. Yeah. So now it will be 80 meters, not 100 meters. Let's say make it 60 meters. Now there will be less number. So if I just show you like that. So if I say my regulation allows me 100 meters, I get more options here, right? And each of them have a value. That means the solid volume, which is 83,160 cubic meters, and surface area. So if I choose another one, you can see here there are different ones. So you can see them in a graph here, on a scatter graph. So the most optimum will be the top one, where the surface area will be the minimum and the volume will be 99,000, something like that. So sometimes depending, because this is a very simple solution, so you have this scatter graph almost like a line graph. But if you have more design constraint, design goals which are very complex, like let's say I want to locate this building in a plot which is a irregular plot, and then I must avoid certain trees, then how can the computer determine where to place the building in the site? So these kind of complex things, we will do it in the class when we learn in detail how to use Dynamo and how to create Dynamo graphs for generative design. All right. Thank you very much. Have a nice day. Bye-bye.